Hi doctor, here is our video to show how the simulation was done for our in-lab experiment 2, that the BJT small signal amplifier. First, we have done the Prelab question before the experiment day that produced the design equation for each resistor R1, R2, RC and RE based on the following information. So here is our Prelab work. Our calculation, and the final answer we get is R1 equal to 153.79 peta ohm and R2 is 30.83 peta ohm, RC is 800 ohm and RE is 200 ohm. Next, we can continue to our in-lab procedure. Part A, which determination of the DC current gain. Here is the formula. Beta DC is equal to IC over IB. First, we construct the circuit in multisim and start simulate it to get the result of IC and IB. So the multimeter has shown the value of the IC is 1.775 milliampere and the value of the IB is equal to 11.21 milliampere. So this is for the variable resistor is equal to 1 mega ohm. So we can get the DC current gain is beta is equal to 158.34.
Okay, I will present about part B. This is the circuit of part B. We construct the circuit by referring to the value of R1, R2, RC and RE from the prelab we have done, and also by referring to the part A for the beta voltage gain. So for the beta voltage gain we get is 158.34. This is referred for the simulation we have done in part A, and we substitute this voltage gain into the formula we have generated for our prelab, which is R1 is referred to 503.79 multiplied with the beta, we get 2435 ohms. For R2, we get from the prelab is 38.83 multiplied by the beta, and the value we get is 4881 ohms. And RC and RE is based on the prelab that we have calculated. Okay, after we run the simulations, okay, we get our voltage of CE is 6.25, and for the IC is 5.738 milliampere. So this is the data we get, and by referring back to the prelab for voltage CE, in prelab we get 6. So if we calculate the percentage of error, we get 4.1%. For ICQ, the value we calculate from the prelab is 6 milliampere, and the actual value we do in the simulations is 5.738 milliampere, and roughly a slightly different of 4.4% of percentage error. So after the simulations, we can observe that there is a slightly differences between the theoretical value and the simulation value. Since we are doing simulation, not the real actual experiments in the lab, so a few factors that we can neglect is that one is the resistance of wire, and next is the loading effects of the electronic measurements. So that's why our differences between the simulation value and the theoretical value is very small.
So I will present about the part C, small signal amplifier. So the question asks us to connect a circuit like this by filling in the values of capacitors. So there is 3 set of capacitor value, and then the question asks us to put in the input voltage signal, which has the 10 kilohertz and 100 milli peak to peak voltage. So, and then we want to convert the voltage into the VRMS. So the V peak is equal to the V peak to peak divided by 2. So divided by 2, and then the VRMS is equals to the V peak divided by sub 2, and then we get 35.36 milliwatt. So in our circuit, we put in the capacitor value and the 35.36 VRMS, and then this is for the cycle 1, the set 1 capacitor value, and then we want to check the output waveform to make sure there is no distortion. So check the output waveform, there is no distortion. And then this is the cycle 2, we put in the capacitor value in the set 2. So same thing, we check the output waveform, so there is no distortion occurs. And then this is the cycle 3, we use the capacitor value from set 3, and then we check the waveform. Okay, there is no distortion in the waveform, so then we can proceed. The question asks us to measure the input voltage and the output voltage. So we use the multimeter to measure the input and output voltage. So this is cycle 1, and then so we want to change the multimeter to the AC to measure the AC voltage. So we get the values like this, and then cycle 2, then we go to cycle 3. This is cycle 3, and then we simulate it. Okay, we get the output voltage and input voltage, so we group it in the table. We can observe that the input voltage and output voltage from the 3 cycle is almost the same. And then the question asks us to calculate the no load AC voltage gain. So from here we choose one set of value, so we choose cycle 2, this cycle 2, and then we use the formula to calculate the gain, so which is the output voltage divided by input voltage, and then we log it and times 20 to get the value in decibel form. So we get 11.77 decibel. And then the question asks us to add 2 more capacitor to the circuit, and then repeat the step 3 and step 4. So we add the 2 capacitor here. This is cycle 1, and then we simulate, we see the waveform. There is no distortion here, and then we measure the input voltage and output voltage by the multimeter. put it in the AC. So we simulate, we get this value, and then we go to cycle 2. Cycle 2 same, we want to see the waveform. So no distortion occurs, and then we see the multimeter, the voltage, and then we go to cycle 3. This is the cycle 3 set of value. So same thing, we observe the waveform first. So no distortion occur, and then you see the multimeter value. So after we measure the value, we put it into the table, cycle 1, cycle 2, cycle 3. So we observe that the input voltage is similar, and then the output voltage is almost the same, only slightly different because of the difference of the capacitors value. And then we just choose one set of the data, so we choose cycle 2 value, and then we put it into the formula. The same thing, V out divided by V in, and then log it times 20, we get 29.9 decibels. That's all for me. Thank you.
So that's all the simulation and calculation our group had done in lab experiment 2 week 1. So here the discussion. The characteristic of the amplifier that we can observe is in the experiment, the output voltage is amplified from 137.015 millivolt to 1.105 watt. So next, for the voltage gain I'll calculate is increased from 11.77 dB to 29.9 dB. Therefore, it can prove that the BJT is in active region and act as a amplifier. Next, a simple statement about the effect of C3 on the magnitude of voltage gain. For C3 is act as a bypass capacitor to make the resistor R5 short circuited. The resistor R5, which is the 0.9 RE. Capacitor can block direct current and allow alternating current to pass. Due to this, capacitor often extremely high resistor to DC and a lower reactance to AC. When C3 is placed in the circuit, DC is not affected, but AC has a pound of lesser resistor when flowing to the C3. Thus, less AC reactance lead to more AC current to flow. The AC current IB and IC will have increases. The more AC current flow through the R3, which is RC, the more voltage is developed across R3. Hence, voltage gain will be increased and can be calculated with the formula. So in this experiment, the measure value of the voltage gain without C3 is 11.77 dB, and the voltage gain with C3 is equal to 29.9 dB. That's all. Thank you.